Hello class, welcome to the next segment in the week 1 material, and in this next segment we're going to talk a little bit more about variables, but the main emphasis for this segment will be on the mathematical operations, the basic mathematical operations that we can perform in Python. So to start off with, we'll go ahead and take a look at the very top of the program, which is where the computer is going to be starting, so it makes sense for us to start up there as well. And up here we have two variables defined. On the very first line we have a variable x being set equal to a number of 3, and then we have the value of 10 being stored in a variable called y. And one thing that's going to be important to emphasize is for each individual piece of information that you want the computer to keep track of, you must set aside a separate variable for it. So you can't use the same variable name to hold on to every single piece of information. That's just not going to work at all. For each individual piece of information, you want to have a separate variable set aside for it. So in this case, we have two pieces of information that we want the computer to keep track of. One of which is the number 3, which x is holding on to, and the variable y is holding on to the other piece of information. So here I have two pieces of information, two variables, and we're all good to go. And if we look down here on line 4, we have a variable called the sum. And there's nothing special about this variable. It's, again, sort of an extension of what I was talking about in the previous segment, how it's a good idea to make your variables self-explanatory, sort of make your variables represent the value that they're holding on to. In this case, the sum is holding on to the result of two numbers being added together. So here I have the sum being set equal to the value of x. So here the computer is going to read this off as look what the value of x is, which is 3, and look up what the value of y is, which is 10. Then once you have those two values, add them together to get a result, and then take that result and put it in whatever's on the left-hand side. So here the computer is going to compute the result of x plus y, which from up here we can see that will be the result of 3 plus 10, which should be 13. And we take the result and store it on the left-hand side, so our variable called the sum should hold on to a value of 13. And we should be able to verify that by looking at the result of the print statement that's on line 6 here. So if we go ahead and run the program, we'll see that the sum is in fact equal to a number 13. And one thing I'll go ahead and demonstrate, which is kind of shown up on the screen here, is you might be wondering, okay, that's kind of the same thing as doing this, right? Can I just say the sum is equal to 13 in these quotation marks? Well, the answer is yes, but this may not go the way that you want it to. So here, it looks like I get the same exact result. But let's say I go up here and change the values of x and y. So here I'll make y 15 instead of 10. So here I'm going to get the sum being equal to 3 plus 15, which should be 18. And again, that value goes in a variable called the sum. But here, in this print statement, I'm still telling the computer to print out the sum equals 13. And that might be slightly confusing because you might be wondering, why isn't print out the sum equals 18? And the reason why is because, remember, whatever appears in between quotation marks in a print statement, the computer is literally going to print that. So we've literally told the computer that we want to see the sum equals 13 in the console, as opposed to what we had before, where we had something like this. We already have the sum equals, and then this unquoted segment means look up what the value of the sum is at this point in the program and print out what its result. And if we do this, then we get the result that we actually want. So here, again, just sort of reiterate, here I'm literally telling the computer what I want to see in the console. I want to see the sum equals 13, and I'm telling it to literally do that because I have the quotation marks. Versus when I had this situation where I have an unquoted part of the print statement, which means look up what the value of this variable is and print out what the value of that variable is. So it doesn't matter what I change these numbers to, I will always get the value of what the sum actually is, versus in this case, here I pretty much have a broken clock. I've built a broken clock. It tells me one thing only. It might be right once in a while, but in general, it's not going to give you the result that you're looking for. So in that process of making the computer print one thing and one thing only, even though it's not actually reflecting the changes made in the program, that is termed hardcoding. It's where the computer pretty much says the same thing over and over again, even though it shouldn't be saying the same thing over and over again. So just something to keep in mind. Make sure that if you want to print out what the value of a variable is, make sure that you're printing out something that's unquoted. Otherwise, the computer is going to tell you one thing and one thing only each and every time, all the time. So that's sort of a look at hard coding and also the addition operator. And if we jump down here, we can see some examples of subtraction. So I'll go ahead and disable what's on line 6 and then go down to here on line 16 and 17. Excuse me. So here on line 13, I have a variable called oneDifference, and we're setting that equal to the result of y minus x. So just like in your regular math classes, the order of subtraction is important. So in a case of addition, it doesn't matter what order the addition is performed in, but subtraction, that is in fact something that's important. The order is in fact important. And the computer will actually follow order of operations. So in general, it will try to go from left to right unless there's an operation, some sort of mathematical operation that has higher priority. So in this case, it's going to take the value of x, which is still 3. We haven't changed that. Notice I put these two back to the values that we started with. It's going to take the value of x, which is 3, the value of y, which is 10, perform 3 minus 10 to get a result of -7. And then down here on line 14, I have another difference being set equal to the value of y minus the value of x. So in this case, y is 10, x is 3, so I get 10 minus 3, which is 7. So oneDifference is going to hold on to a value of -7, but this variable, another-difference, will hold on to a value of +7. And we can verify that by looking at what the program tells us, and it does in fact arrive at those results.